Well, let's try negative 3 as a potential root. So let's again use our synthetic division. Bring the 1 straight down. Now start your multiply, carry, add. Negative 3 times 1 is negative 3. 6 added to negative 3 is 3. Negative 3 times 3 is negative 9. 11 added to negative 9 is 2. Negative 3 times 2 is negative 6. 12 added to negative 6 is 6. Ooh, this is looking better. Negative 3 times 6 is negative 18. 18 and negative 18 is 0. I have the remainder of 0, which tells me negative 3 is one of my real roots, one of my real zeros. And the factorization would be x plus 3. It's always x minus whatever the root is. X minus negative 3 would be x plus 3. And the reduced polynomial would be, okay, the highest power here was 4, so the highest power here is going to be 3. The reduced polynomial is x to the third plus 3x squared plus 2x plus 6. And this is now the polynomial for which I need to find zeros. Well, negative 1 and negative 2 can't work because they didn't work for f of x, so they can't make this quantity become 0 because this quantity is a factor of that original quantity. So if negative 1 or negative 2 made this quantity become 0, they would have made the whole polynomial function become 0. But negative 3 worked once. And as we saw in the previous video, we had negative 1/2 with a multiplicity of 2, meaning it was a factor twice. So before I go on and check any others, I should probably check to see if negative 3 works here again. So let's try negative 3 with synthetic division now using these coefficients. Bring down the 1. Negative 3 times 1 is negative 3. 3 plus negative 3 is 0. Negative 3 times 0 is 0. 2 plus 0 is 2. Negative 3 times 2 is negative 6. 6 plus negative 6 is 0. It did work again. So negative 3 is a 0 twice, or we say negative 3 is a 0 of multiplicity 2. The remainder of 0 told me it worked again. And now the reduced polynomial that I'm working with is x squared. See, it's 1 less than that. Well, there's no first power term. The coefficient of the first power term would be 0, so it's x squared plus 2. And now I could try to solve that quadratic equation to see what values of x make that 0. So I just set it equal to 0 and solve. Oh, quadratic equation where the first power term's missing. That's where we want to use the square root property. So x squared equals negative 2. X equals plus or minus the square root of negative 2, which is plus or minus 2i, which are not real zeros. They are complex zeros. So this particular polynomial function had 2 negative real zeros and 2 complex zeros. And since we're only interested in the real zeros in this exercise, we would say that these are the real zeros. Negative 3 was a real 0 of multiplicity 2. Its factorization of that polynomial would need to have 2 binomials, x plus 3, and the other factor would be x squared plus 2, what we call an irreducible factor. And in that instance also it's an irreducible quadratic factor. So here are the real zeros and the process we went through to find them for that given polynomial function.